Alright, so today we're solving linear systems, so systems of equations, by using a different process called elimination. Sometimes people like this a little bit better. It's less work than substitution, but a little different, a little weird. Sometimes it'll be more convenient to do this rather than substitution. So the first thing we want to do is we want to arrange our equation with like terms in the same column. So we're going to basically put them in standard form. What we'll do is we'll have our x's first, our y second, and then our regular number on the other side. Second, and this is the main part of elimination, is we want to multiply one or both of our equations by some number. And this is the part that's a little tricky about it, is we want to multiply it by some number so that the numbers, one of my variables, are opposites of each other. So I'm trying to get my x's to be opposites of each other or my y's to be opposites of each other. Here's just a little reminder, because we always screw it up, is opposite means same number and different sign. So when I'm looking for opposite, I'm looking for the same number with a different sign. Once I get that, once I get opposites in my x or y column, then I can go ahead and add my equations together. What will happen is when I add them together, since one of the columns will be opposites of each other, one of the columns will disappear, giving me a 0, and I'll just have one variable left. Fourth thing that I'll do is then, once I have one variable, or I know what one variable is equal to, I got to plug it back into one of the originals to find the other answer. Just like we did with substitution. So with the first one, it's pretty easy. The very first thing, make sure that my x's are in the first column, y's in the second column, then numbers in the last column. So x's, same column, y's, same column, numbers, same column. So what I can do is, and what you'll notice is my y's are already opposites of each other. They are both 3's, and then one is positive and one is negative. And so what I can do is I actually can skip my second step and just add my equations together. So I'm just going to add these equations together. So I get 6x plus 3y plus negative 3y gives me 0y is equal to 24. Again, 0y is the same thing as nothing, so I can kind of get rid of it. I have 6x is equal to 24. And then divide both sides by 6. So I get x is equal to 4. Once I'm there, then I want to plug that into one of the original equations. It's a little different. It doesn't matter which one you plug it into. I'm going to plug it into the second equation. So I can go 2 times 4 minus 3y is equal to 8. So I get 8 minus 3y is equal to 8. Subtract the 8 to the other side. Get negative 3y is equal to 0. Divide both sides by negative 3 and get y is equal to 0. So I know, again, it's got to be an ordered pair solution. So I know my ordered pair solution is going to be the ordered pair 4, 0. Again, I always want to double check my answers. So once I have my ordered pair solution of 4, 0, I want to plug it in for both equations. So plug a 4 in for x and a 0 in for y, a 4 in for x and a 0 in for y. So on the top one, 4 times 4 gives me 16. 3 times 0 gives me 0. Checks out. Bottom one, 2 times 4 gives me 2 times 4 gives me 8. 8 minus 0 gives me 8, so I know it checks out in both of them. With the second one, I have a little bit of work to do to get them to be in the same column. So the first thing that I want to do, again, I want my x's to be in the first column. So I've got to move this 2x over to the other side, so I'm going to add it to the other side. And remember, with standard form is I want my x first, my y second, constant term on the other side. So I'm going to go positive 2x minus 2y is equal to 2. Bottom equation is going to be 2x plus 3y is equal to 12. These are close, but right now, again, I want to get opposites. These are the same number, but they're not the different sign. So what I need to do is, to get them to be the same number with a different sign, is I want to change this into a negative 2. So again, I have to multiply everything. So what I multiply 2 by to get a negative 2 would be a negative 1. So I'm going to multiply everything in the top equation by negative 1. Gives me 2 new equations. So I get my new top equation is negative 2x plus 2y is equal to negative 2. Then I have 2x plus 3y is equal to 12. Now I have opposites. They are same number. They are different signs. So I can add these columns together to get 0x plus 5y is equal to 10. Get 5y is equal to 10, and then divide both sides by 5. Get y is equal to 2. Again, once I have one of my variables, I want to plug it into one of the originals. Let's plug it into the bottom one. I think that'll be easier. So I get 2x plus 3 times 2 is equal to 12. So I get 2x plus 6 is equal to 12. Subtract the 6. 2x is equal to 6. Divide by 2. X is equal to 3. Again, I want to plug it into the original. So, whoops, the ordered pair is 2, 3. So 2 for x, 3 for y. 2 for x, 3 for y. So on the top, I get negative 6 is equal to 2 minus 4. I wrote my ordered pair down wrong. Hold on. Oh my goodness, can't believe it. This should be ordered pair 3, 2. I'm sorry. Probably all watching this video thinking I'm an idiot. There we go. So 3, 2. There we go. 3 and 2. 3 and 2. So I get negative 4. And then 2 minus 6 gives me negative 4. This one works out. Bottom one, 2 times, that gives me 6. Plus 6 is 12. That's true as well. Down at the bottom of the page, do one on the bottom left-hand side. So again, x's are in the same columns. I got x's, y's, constant terms. So that's taken care of. Just want to get one of them to be opposites of each other. So the easiest one it looks like is my y column. They're already different signs, so I just need to get them to be the same number. So to get them to be the same number, to turn a 3 into a 6, this negative 3 right here, into a negative 6, I would want to multiply this one by a 2. So I'm going to multiply the entire top by 2, which would give me 18x minus 6y is equal to 40. On the bottom, I would get 3x plus 6y is equal to 2. Again, just a double check step, different signs, same number. Go ahead and add them together. So I get 21x plus 0y is equal to 42. And then I can divide both sides by 21. Get x is equal to 2. Once I'm there, then I can go ahead and plug this back into one of the originals. I'm going to plug it into the bottom one because I think that'll be easier. So I get 3 times 2 plus 6y is equal to 2. So I get 6 plus 6y is equal to 2. Subtract the 6 over to the other side to get negative 4. Divide both sides by 6, and I get y is equal to negative 2/3. So again, I can plug that. That's my ordered pair 2 and then negative 2/3. And so again, I can plug this back into the original. X gives me 2 and then negative 2/3. It's negative, yep. 2 and negative 2/3. It gives me 18 minus negative 2, which is the same thing as plus 2, gives me 20. That works. And then 6 plus, let's see, 6 plus negative 4 gives me 2. Yep, that works out as well. Okay. With the bottom right one, this is where they start getting more difficult. When I look at this, x, y's, same column, there's no easy way to turn 3 into a 4. There's no easy way to turn a 5 into a 2. And so what I'm going to have to do here is I have to multiply both equations. So I'm actually going to look at my y column here because I think that's going to be a little bit easier. And this is where I want to turn the 5 and the 2 into the same number. So kind of an easy way is by finding the least common multiple, which is just thinking about a number that I can multiply both of them by to get the same number. So if I multiply the top by 2 and then the bottom by 5, I would get them to both be 10s. They would both be positive 10s, so I'd have to make 1 a negative. So easy way to do least common multiple is just multiplying the two numbers together. So 5 times 2 gives me 10. Then I can figure out how to turn each of those into a 10 and just make sure that they are different signs. So I'm going to multiply the top by negative 2 and the bottom by positive 5. So I'm going to get negative 6x minus 10y is equal to negative 12. Sorry, got it cramped in there. On the other side, I would have negative 20x plus 10y is equal to 25. And so then, again, just double check, same number, different sign, I'm good. So I can add these together and get negative 26x plus 0y is equal to, that's going to give me 13. Again, 0x or 0y doesn't matter, divide both sides by negative 26. I get x is equal to negative 1/2, or negative 0.5. Once I have one of my answers, I want to plug it back into one of the originals. The originals are always going to be smaller numbers, so that'll be kind of easy. I think the bottom one's going to be easier, so I'm going to go negative 4 times negative 1/2 plus 2y is equal to that's positive 5. So when I multiply these guys together, I get positive 2 plus 2y is equal to 5. Subtract the 2 to get 2y is equal to 3. And then divide by 2 to get y is equal to 1.5. So my ordered pair solution is the ordered pair negative 1/2, positive 1 1/2, or if you want to write it as a decimal, negative 0.5, positive 1.5. So again, I do want to double check these, plug them back into the originals. So negative 0.5, 1.5, negative 0.5, 1.5. Again, I can just type it into my calculator. 3 times negative 0.5 plus 5 times 1.5 equals 6, so I'm good. And the bottom one, negative 4 times negative 0.5 plus 2 times 1.5 is equal to 5. Check. So they both check out, so I know I did it right. Go ahead and flip over to the back. On the back in the top left side, again, it's one of those same kind of difficult ones. So the first thing that I want to do is go ahead and find a least common multiple. How about I do my y's? Since they're already different signs, I just need to turn them into the same number. And so when I do that, again, the least common multiple of 4 and 9, I can turn them both into 36. At the lowest one? Yeah, I think it is. So I'm going to multiply the top by 9 and the bottom one by 4. So when I multiply the top by 9, I get 45x plus 36y is equal to negative 270. And then on the bottom one, I should get 12x minus 36y is equal to negative 18 times 4, which gives me 72. Again, I've got the same number, different sign, so I'm good to go. I add these together and I get 57x plus 0y is equal to negative 342, I believe. Yep. And then I can divide both sides by 57. I get x is equal to negative 6. Again, I can go ahead and plug this back into one of the equations. I think it's going to be easier to plug it into the bottom one because I've got smaller numbers. So I have 3 times negative 6 minus 9y is equal to negative 18. Negative 18 minus 9y is equal to negative 18. Add the 18 to the other side. Get negative 9y is equal to 0. So y is equal to 0. Divide both sides by 9 and get y is equal to 0. Again, when I plug this, so that's my ordered pair solution, is the ordered pair negative 6, 0. Plug it back into the originals and double check your answers. Then with the last one, again, same thing. I think it's going to be easier with smaller numbers is if I multiply or if I get my y's to be the same number with a different sign. So again, least common multiple, easy to just do 7 times 2 to give me 14. So I'm going to multiply the top by 7 and the bottom by 2. That'll get my y's to both be 14s. One's negative and one's positive. So I get negative 28x minus 14y is equal to 14 times 7, which gives me 98. And on the bottom, I get negative 20x plus 14y is equal to negative 50. So I get negative 48x plus 0y is equal to 48. Positive 48, yep. Divide both sides by negative 48. And I can get x is equal to negative 1. Again, plug it back into one of the originals. I think the top is going to be easier. Negative 4 times negative 1 minus 2y is equal to 14. So 4 minus 2y is equal to 14. Negative 2y is equal to 10 by subtracting the 4 to the other side. Y is equal to negative 5 by dividing both sides by 2. So the ordered pair solution is negative 1, negative 5. And there we go.